Hey, Mr. Harrod, here. We're going to go over significant figures. What are significant figures? These are numbers that have meaning. In other words, there are numbers that are significant. Okay? This all has to do with the precision of your measurements. That's why significant figures are important. Okay? If you do not use significant figures on your calculations, there will be a significant deduction on your quiz. Okay? So here are the rules. They are really significant. Rule A. All non-zero digits are significant. Rule B. All leading zeros are never significant. So this would have one significant figure, which would just be the 1. Okay? Middle zeros are always significant. So the 2, the 0, and the 4 here are all significant. So this would have 3 significant figures. Okay? Trailing zeros are significant if and only if there's a decimal present. 2, 1, 0, there's a decimal present. This would be 3 significant figures. Now, if there is not a decimal present, like 4,200, we only have 2 significant figures. Those other 2 zeros are placeholders. Okay, so that's somewhat how significant figures work here. There are other ways to do this as well. There's the MAP method, which you'll see me occasionally use. So we know the Pacific Ocean is on the west coast and the Atlantic Ocean is on the east coast. The Pacific Ocean has decimals present, so like 34.00. Okay, you start from the left, you go to the first non-zero digit. Okay, it's very important, first non-zero digit, and then you underline everything else beyond that non-zero digit. So this would have 4 significant figures. Okay, if the number was 0.000320, you start over here on the west coast, you go to the first non-zero digit, which is the 3, and then you underline. That would have 3 significant figures. Okay. Now, if there is no decimal, you go in reverse. Okay. So something like 41300. The Atlantic Ocean is on the east side. So we go over to the right side. Again, we go to the first non-zero digit and chop. So this would have 3 significant figures. The key to doing this method is you have to figure out if it has a decimal or not. If it has a decimal, you start on the left side and go to the first non-zero digit. If it does not have a decimal, you start on the right side and you go to the first non-zero digit and count. Okay, so here we go.
Prepare for battle.
Okay, we are preparing for battle on example 2.8. Okay, decide the number of significant figures in each of the following here. So we're starting off with 100 here. This is no decimal. So we're going to go this way to determine the number of significant figures and cut at the 1. So this has 1 significant figure, because this is rule D. Okay, this one is also rule D, but this one has a decimal. Trailing zeros count with a decimal, so we're going to go this way. So this one has 3 significant figures. Okay? This is also rule D with a decimal. So we are going to go this way. We stop at the 1 and then we underline. This would have 4 significant figures. So this measurement would be more precise than this measurement based on the number of significant figures. Okay, so now we have a decimal here. This is rule B. Leading zeros never count. So we pass those and go to the 4. So this would be 2 significant figures. This is rule B and D, and it has a decimal. So we pass the leading zeros to go to the 4, and then underline. These are trailing zeros, so those count. 4 significant figures. Okay, let's go to the other side over here. Okay, this is a decimal. This is rule C. Middle zeros count, so you stop at the 1 and underline. 5 significant figures. This is no decimal. This is rule D. It has trailing zeros because it trails the number. So we go this way. And this one has 2 significant figures. This is a decimal. This is rule D. Okay. So we go from this side to the 9 and underline the 8. 4 significant figures. Okay, so this is scientific notation here. You count the front. So you just count the front part on these. You don't count times 10 to the third. So this one has 2 significant figures. And this one has 3 significant figures. How was that? That was
legendary.
It was. On to page 12. Okay. Moving on here.
Prepare for battle.
Yes, prepare for battle again, because now we're going to do it with calculations now. So here, the multiplication and division rule. Okay, here we go. The number of significant figures in the final answer is determined by looking at the original numbers used in the problem. The original number that has the smallest number of significant figures determines the number of significant figures in the answer. Okay? There is something called exact numbers. Exact numbers are like 60 minutes. There's exactly 60 minutes in 1 hour. These have infinite significant figures. Okay? Let me show you what I mean by this. We are going to multiply 89.5540 by 43.10. 89, clear. 89.5540 times 43.10. Okay, so there's my answer. This is what I would call the math answer. The 3859.7774. Never want the math answer. So here's what I have to do here. How many sig figs are in 89.5540? There are 6 sig figs. Okay. In 43.10, there are 4 sig figs. Which number is smaller between 6 and 4? The answer is 4 sig figs. Okay? So, if I was rounding this answer to 4 sig figs, okay, there are two ways to do this. 3859.7774. Okay? The fifth digit right here is a 7. So this is going to go up to a 0, and this is going to go up to a 6. So I have to put 3860 with a decimal point. Because if I do not put the decimal point, this 0 is not significant. But with the decimal point, this 0 is significant. Or you can write this answer in scientific as well. 3.860 times 10 to the third. Either way. Okay. Let's look at the next one. We divide 3380 by 457. Okay. And we get 7.396061.269. Don't want that answer. That's a math answer. That has nothing to do with significant numbers, significant figures. How many significant figures are in this number? 3 sig figs, because this 0 does not count. How many significant figures are in this number? 4 sig figs. Okay. 3 sig figs and 4 sig figs. The fewest number is 3 sig figs. Okay. So our answer is 7.396061.269, right? Go to the fourth digit. That's a 6. So we're going to round up. So this becomes a 0, and that becomes a 4. 7.40. That's the correct answer. You can also write 7.40 times 10 to the 0, but I really don't want to see 10 to the zeros. Okay, the next one. 0.006750. This one has 4 sig figs. Divided by the exactly counted number of 32. This one has infinite sig figs. So what is less between 4, sorry you can't see what I'm writing here, and infinite? Why 4, of course. Okay, so let's do this calculation on the screen here. 0.006750 divided by 32. Oh, this one comes out in scientific. How nice. So I'm going to write down the answer in scientific. 2.109 times 10 to the negative 4. Because I want 4 significant figures, so I just chop off the 3. Or that would be 0.0002109 if you're writing it as a regular number. Okay, last one here. We'll do this one really quick here. Ooh, you can't see that color. That's a bad color. Bad candy. This one has 4 sig figs. This one has 3 sig figs. So which one has the fewest? 3 sig figs. Okay. So here we go. 3 sig figs here. 278.4 times 25.2. Okay, so this one's a little tricky here. Of course it is, Mr. Harry. So my math answer I got was 715.68. So I'm going to round to 3 sig figs. So this 5 rounds up to a 2. Okay? So I'm going to write down 702. But remember, the math answer here is 7,000, not 700. So you have to add the 0 without a decimal point to make it the correct number. Because if I owed you $7,000 and you give me 702, I give you 702, you'd be pretty mad at me. Or you can write it in scientific, which would be 7.02 times 10 to the third. Okay? Let's pause here for a commercial break. Okay, going over the determination of significant figures with adding and subtracting. When adding and subtracting with significant figures, the result is the same number of decimal places as the measurement with the fewest number of decimal places. So here we're going for fewest, okay? Number of decimal places here. So for example here, if we were adding 78.267 to 1.1 here, this one only has one significant figure after the decimal place, so this is the shortest number. You're always looking for the shortest number. So this is the math answer. Okay. 79.367. I don't want the math answer. So you're going to chop here. Since this is a 6, you round it up to a 4. So the answer is 79.4, which is the same as your shortest number. Okay. Same thing here, 8.190 minus 5.6798. This is your math answer. You have to go with the shortest original number, which is 8.190. So you're going to chop here. Since this is a 1, you just cut it off. Okay. So, here we go. Add 6.98 with 8.28 plus 5.789. So, this number's to the hundredths. And these two numbers are to the thousandths. Right? So, the answer for my decimal place here is at the hundredths. Ooh, that's a pretty color. That is where I'm going to round my answer to for significant figures. So I'm going to do 6.98 plus gotta type the numbers in right, Mr. Aaron. 0.828 plus 5.789. I get 13.597. I'm rounding to the hundredths place. Yes. So the 7 rounds this up to a 6. So my correct answer for this is 13.60. Okay? Here, this is to the thousandths place, and this is to the tenths place. The tenth is the shortest, right? So I'm going to round my answer to the tenths. And this is what we do for adding and subtracting. Remember, there's a different rule for multiplying and dividing. So then you do 8.3 minus 7.456, and you get 0.754. The tenths place is the 7, so we look at the hundredths place, that's a 5, that's going to round up. So the actual answer to this is 0.8. Okay, you guys are champions. The legend is